Hello students, how are you? In the last video, we talked about different types of numbers. We talked about natural numbers, whole numbers, integers, rational numbers, and so on. However, we have not yet come to the name of the chapter, which is real numbers. We talked about rational and irrational numbers also. Now, can you guess what is a real number? A real number may be rational or irrational. All the numbers together, both rational and irrational numbers together, form real numbers. Anyway, we'll come to that later. There's an interesting puzzle today. The puzzle is there on your screen. Let's read it. A trader was moving along a road selling eggs. An idler, who didn't have much work to do, started to get the trader into a worldly duel. This grew into a fight. He pulled the basket with eggs and dashed it on the floor. The eggs broke. सब टूट गया. The trader requested the panchayat to ask the idler to pay for the broken eggs. The panchayat asked the trader how many eggs were broken. He gave the following response. Now that is the puzzle. There's a background story. There was a trader selling eggs. A jobless person, an idler, started an argument with the trader for no reason. The argument grew into a duel. They had a fight, and the idler dropped the basket which had the eggs. All the eggs broke. So the trader complained it to the panchayat, and the panchayat asked how many eggs were there in the basket which were broken. Now, instead of giving a simple reply, the trader gave a very interesting puzzle to the panchayat. What is the puzzle? If counted in pairs, 1 will remain. If counted in threes, 2 will remain. If counted in fours, 3 will remain. If counted in fives, 4 will remain. If counted in 6, 5 will remain. If counted in 7, nothing will remain. My basket cannot accommodate more than 150 eggs. So now you have to find out how many eggs were there in the basket. What can you do? It is given. Okay, let's try to see the process. How can we solve this puzzle? First of all, what can we do? Okay, let me make some space on this board first. Yes, is it okay now? Everything is visible? First line is not. Yes. Now it says, let's assume that the number of eggs in the basket were A. Okay. So now what is this number A? If we count it in twos, and let's say we take out 2 eggs from the basket some n number of times, then how many will remain at last? Only 1 will remain. Again, if we take 3 eggs from the basket some n1 number of times, how many will remain at last? 2 will remain. Now you cannot take out 3. Again, the third line says if you take out 4 from the basket, let's say n2 number of times, then only 3 are left at the end. Now you cannot take 4 eggs at all. Similarly, this A is also equal to 5 into n3 plus what remains at the end? 4. And this A is equal to 6 into n4 plus what remains at the end? 5. And also this A is equal to 7. If you take out 7 eggs and 5 number of times, what is remaining over there? Nothing, plus 0. Everything is over. Okay. So this 0 is not required over here. So do you understand the puzzle? Do you understand the question that's there on the screen? And the steps that I have written? you have so many number of equations. This is equation number 1, this is 2, 3, 4, 5 and 6. And how many variables do you have? 1, 2, 3, 4, 5, 6 and 1, 7. So many variables are there. Too many variables. So we'll not try to solve it this way. It's not a proper method to solve this question, but I'm just telling you how to frame the equations. Getting my point? This is how you can frame the equations. Now, in order to solve the questions, what you can do is, we know that the basket did not have more than 150 eggs. Basket had something less than 150 eggs. And the number of eggs was a multiple of 7 as it is given in the last statement. So you need to guess one multiple of 7 which is very close to 150. Let's take it 147. That is the largest multiple of 7, less than 150. Now start counting backwards. Will 147 satisfy all the equations? If not, move to the next multiple of 7, that will be 140. Now again check, will it satisfy all the equations? If not, then move to the next multiple and so forth. Okay. I will come to a better method to solve this question later on. But as of now, you can try with this method. Okay. Now, this puzzle was not there for you to solve. This puzzle was there for you to understand something. What is there to understand in this? Okay, listen carefully here. We have seen here A is the number of eggs. We are always talking about the number of eggs in the basket, which is A. Isn't it? And we know that when we divide this A by 2, we get a quotient as n and remainder as 1. We are getting one quotient and one remainder. When you divide this A by 3, you get another quotient and another remainder. When you divide this A by 4, you get yet another quotient and one another remainder. And all these n, n1, n2, n3, all these things are numbers, integers. So, when you divide a number, any number A, by any number, this is 5 over here, you get one quotient and one remainder. That is what we are trying to see here. If you divide an integer by another integer, you get a quotient and a remainder. Okay, don't say that you can get a fraction or you can get a decimal number. Let's say you divide 3 by 2. You can say you get 1.5, but we are not interested in this 1.5. We are interested that quotient is 1 and remainder is also 1. We are not interested in this 1.5 here. Okay. Yes, 1.5 is correct answer. I am not saying anything about it. It's not wrong. It's correct. It's very much valid. But we are not interested in this 1.5 here. We are interested in something else. We are interested in one quotient and one remainder. Like you used to do when you were in standard 3 or 4. In the very beginning, when you used to divide, when you learned division process, let's take one number 119 and you divide it by 2. What will happen? 5 times 10, you get 1 over here, 9, you go 9 times 18, you get 1. This 1 is the remainder and this is the quotient. We are interested in this here. We are not interested in anything else. We just need one quotient and one remainder. Okay. If you take any random number and you divide it by any other number, you will get one quotient, one remainder. Okay. So that is the thing we are trying to understand here. If you see this pair of integers, 17 and 6. If you divide 17 by 6, 17 divided by 6, what quotient will get? Quotient will be 2, remainder will be 5. Isn't it? Now divide 5 by 12. What will you get? Quotient will be 0, remainder will be 5. Again divide 20 divided by 4. What do you get? Quotient is 5, remainder is 0. Isn't it? This is as simple as that. We are talking about Euclid's division lemma. I'll come to the name and the technicalities in just in a while. But this is what we are talking about. When you divide a number by any other number, when you divide a number by any number like here, or as in here, or as in here, you get one quotient, 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 and one remainder, remainder, remainder. Enough. Getting my point? Division leads to one quotient and one remainder. Now, do you see quotient can be 0? Did you notice that? This quotient can be 0 also. It's not necessary that quotient has to be a number. It can be 0. Similarly, remainder can also be 0. When you divide, quotient can be 0, remainder can also be 0. These are the things to notice over here. Okay. In all the cases in the previous slide, a number was divided, like number A was divided by number B, and you got one quotient and one remainder. And remainder is always less than this B. Remainder has to be less than B. Remainder has to be less than B. And remainder can be 0 or more than 0. See, remainder can be 0, may be equal to 0 or may be greater than 0, but this remainder has to be less than B. Getting my point? Remainder can be 0 or may more be 0, can be 0 or can be more than 0, but it has to be less than B. And quotient Q can be 0 or Q can be greater than 0. Two cases are there. So you can write it combined as Q can be greater than or equal to 0. Clear? Very simple things. Very simple. Now there are some more examples. Try to see the examples. 10 divided by 3. What will this give you? Quotient is 3. Remainder is 1. 4 divided by 19. Quotient is 0. Remainder is 4. 81 divided by 3. What do you get? Quotient is 27. Remainder is 0. Okay. So this pair is unique. If you take this 10 by 3, quotient has to be 3. There cannot be any other quotient. Remainder has to be 1. There cannot be any other remainder. So these numbers are unique. Quotient and remainder both are unique. There are no two options. There is only one option which has to be there. Quotient and remainder. They are determined. They are fixed. Once you know A and B, once you know this is A, this is B, you know the quotient also and the remainder also. There is no other option there. Getting my point? Let's talk about this 19. 4 upon 19. Can there be any other quotient other than 0? No. Quotient has to be 0. Remainder has to be 4. You cannot get anything else. So, otherwise also, if you know both these things, quotient and remainder, can you determine A and B? No, you cannot. But if you know A and B, you can determine the quotient and remainder. Exactly, you can determine the quotient and remainder. So this is called Euclid's division lemma. Whatever we have talked till now. What have we talked? That when you divide, you get a quotient and remainder, and that's called Euclid's division lemma. So simple as that. You divide it, get a quotient, get a remainder. That is Euclid's division lemma. Nothing else. Okay. So that is the definition statement. Given positive integers a and b, there exist unique integers q and r. Q and r both are unique, satisfying the equation a is equal to b times q plus r, where 0 is less than equal to r and b is obviously greater than r. Okay. This is the Euclid's division lemma. So simple. Take any numbers. Let's take let's say 117, and let's say divide by 51. What will you get? You can write 117 is equal to 51 into 2 plus what will be there? 15. So your quotient is 2, remainder is 15. Isn't it? So take any number, you can find the quotient and also the remainder. Then comes Euclid's division algorithm. So this division algorithm is a technique to find the HCF, highest common factor. You know how to find the highest common factor? Of course, everybody has learned how to find the highest common factor. But Euclid's division algorithm is one more method to find the highest common factor. Okay. We will find the HCF of 455 and 42 using this Euclid's division algorithm. I'll just introduce you to the concept in this class, and then we'll talk about it in detail in the coming video. So what do? We write 455 as 42 into 10 plus what can we write here? What will be the remainder? 35. Isn't it? Now you have to get this 45 to the left hand side here. 42 is equal to, you have this 42 will be the quotient now. This will be the new quotient. Quotient will become A. So this is your A. First of all your A is 455 and B is 42. And you divide to get one quotient and one remainder. This is your quotient and this is your remainder. And you get your quotient and remainder. After that, what do? After that, you'd have to take this 42 and this 35. You have to divide 42 by 35. So what do you get? 35 into 1 plus 7. Now again you have to this 35, divide this 35 by 7. 35 is equal to 7 into 5 plus 0. Okay. So this 7 is your HCF, highest common factor. You can check it. 455 will divide 7. Yes, it will divide. It will give you 65. And of course 35 will divide 7. You will get 5 over here. Sounds complicated? This is the simple technique to find the HCF. Let's do it once again. I'll just explain the entire process. Try to understand the process. You have two numbers A and B. When you divide A by B, you get a Q over here and one R over here. Okay. To find the HCF after this division, what will you do? This B will become A. B will become new A, A1, and this R will become new B. Okay. B will become the A1 A and R will become B. Now to apply this process for 455, A is 455, B is 42. You have to divide 455 by 42. What will happen? We'll get a 10 over here and the remainder will be 35. Again you have to divide 42 by 35. Your quotient will be 1 and remainder will be 7. Then you have to divide 35 by 7. Your quotient will be 5 and remainder will be 0. When you get 0, you have to stop over here, and this number is the HCF. The second B, last B which you have is the HCF. Okay, so you get the HCF to be 7. You can take any other example and check. Okay, let me give you one more example. 510 and let's say 44. 68. 68. Okay, so you have to divide 510 by 68. What will you get? Let's do the division over here. 510 divided by 68, 7 times 5, 34. Okay, so you get 68 into 7 plus 34. Now 68 will become your A is equal to, here you get 34 into 1 plus, what will be the remainder? When you divide 68 by 34, you have to divide this 68 by 34. It will go by one time, 34. Okay, two times. 34 into 2 plus 0. So this 34 is the HCF. You can check it. Will 34 divide 510? 510 divided by 34. 1, 34, 1705. Yes, 34 is the highest common factor. Got it? Okay, we'll talk more about it in the coming class. Till then, bye.